A few weeks ago in lab, I demonstrated how to reformat a certain data set so that correlations could be calculated with all of the variables. And in this video, I'm going to redo some of the steps that I did in lab, just so you can have a resource you can go back to as you work on your own projects. And before I move on, I want to mention that this video is only for people who are doing correlational studies and calculating correlation coefficients. If you're doing some other type of study, I'll be working with you one-on-one and showing you what steps you need to do for your project. So let's go to this data set right here. This is a data set that I just made up in Google Sheets. It's from an imaginary survey. So we're imagining someone did a survey asking college students, what is your housing situation? Is it on campus or off campus? What is your major? What is your grade level? How often do you procrastinate from 1 to 5? And finally, what's your overall GPA? And I'm going to show you how to calculate some correlations with this data set. But first of all, we have to reformat it so that we can actually calculate correlations with any of these variables in here. So first of all, if it's okay to have categorical variables like housing situation or college major, but if we want to calculate a correlation coefficient, the categorical variable has to have 2 categories only. It can't have 3 or more. So if a categorical variable has more than 2 categories, we're going to have to break it up into separate variables so that those variables have only 2 categories each. So and the second thing we're going to need to do is turn everything into code numbers, because we can't calculate correlations if it's written in words like it is right here. So first of all, let's turn housing situation into code numbers. And the 2 numbers can be whatever we want them to be, as long as we use them consistently. But to keep things simple, let's just use 1 and 2. So let's say 1 is on campus and 2 is off campus. So like I said, I can use whatever 2 numbers I want to, as long as I use them consistently. And also I have to remember what each number stands for. So if I say that 1 is on campus and 2 is off campus, I have to remember that I assigned 1 to on campus and 2 to off campus. I have to know what each number represents. So let's do that right now. So like I said, 2 is off campus, 1 is on campus, 2, 2, 1, 2, 1, 1. Now we have college major, and I'm going to need to break up this variable into separate variables so that each of my variables so that each of my categorical variables is limited to 2 categories only. So what I can do is just create a variable for each of my categories. So let's start with psychology. So what we're going to do now is for each person who's a psychology major, we put 1 for yes, and for each person who's not a psychology major, we put 2 for no. So now we're just imagining that instead of asking what's your grade level, instead of asking what's your college major, we just asked, are you a psychology major? And we got yes, no answers. We're just imagining that that's the case. So 1 is psychology, and 2 for everyone who's not a psychology major, which would mean that the first 2 people are yeses and everyone else is a no, because we only have 2 psychology majors in the data set. Now we make a variable for sociology. So this is another yes-no variable, and it's just, are you a sociology major, yes or no? So everyone who's not a sociology major would get a 2, and everyone who is gets a 1. So it's no, no, yes, yes, no, no. Now we move on to engineering. So we only have 1 engineering major, only 1 yes, and everyone else is a no. And we're just going to keep doing this for every grade level until we reach the last category that's in our data set. Looks like the last one is nursing, so we'll stop there. We only have one nursing major. Then we have, well, grade level. So grade level is actually categorical, but it's a different type of categorical variable than college major is, because the the grade levels like freshman, sophomore, junior, senior have a ranking to them. Freshman is the lowest, then sophomore, then junior, then senior. And when when a variable has ranked categories like grade level, you actually don't have to split up the variable, because you can actually just treat it like it's numerical and just assign a 1 to the lowest category, then a 2 to the next highest one, then a 3 to the next one, and the highest category gets the highest number. And then you can just treat it like it's numerical, just like GPA is numerical. So let's do that for grade level. So freshman is a 1, sophomore is a 2, senior is highest, so it would be a 4, junior, junior, freshman. Well, there are some people who would argue that you shouldn't actually take a ranked variable like this and treat it like it's numerical and calculate a correlation, but it's often done in psychological research. It's very commonly done, even though there are people who would argue against it. So that's why I'm I'm having you I'm allowing you to do it, because it's just a common practice. And there is actually a special correlation coefficient for ranked categories, but I'm not going to have you calculate that in this class. I'm just going to have you calculate the same correlation coefficient for all variables. And if you're interested in it, you could look up Spearman correlation coefficient. So that's for ranked data, and the Pearson correlation is actually for quantitative data like heights and weights. The Pearson correlation is what I'm having you calculate in our class. So here we have procrastination. Once again, it has ranked categories, so we're going to treat it like it's numerical. So whatever category is lowest is a 1. So in this case, 1 would be never, 2 rarely, 3 sometimes, 4 often, 5 always. So we're almost at the end. Now we have GPA. We're just going to leave GPA the way it is because it's numerical, so there's no problem with it. It can be entered into any correlation.